Okay, have you ever been staring at a test question totally and completely stumped, and you can just feel your brain turning to static? Well, guess what? In this explainer, we're going to turn that wild guessing into a straight-up calculated science. Yeah, I'm going to show you how math can actually be your secret weapon. You know that feeling, right? That panic. The clock's ticking down. The questions look like they're written in some ancient, forgotten language, and you just start filling in bubbles, praying for a miracle. Come on, we've all been there. But what if you could actually put a number on that hope? I mean, what if you could calculate the precise odds of guessing your way to an A? Well, newsflash, you can. So let's get into it. Let me introduce you to your new superpower. It's called binomial probability. Now, I know what you're thinking. It might sound like something you'd have to buy two of, but trust me on this one, it's priceless.
All right, so here's the official, kind of boring textbook definition. A little dry, right? It sounds way more complicated than it actually is. The only words you really need to focus on are two distinct events. Let's break that down into plain English.
All that fancy definition really means is that we're talking about any situation that has only two and exactly two possible outcomes. You get the answer right or you get it wrong. A coin lands on heads or it lands on tails. A switch is on or it's off. It's all very bipartisan. To really get a handle on this, let's start with the absolute simplest example there is, the good old coin flip. It's the perfect training ground for our new superpower. Think of it like a recipe. Seriously. Step 1, you count your trials. That's just how many times you're going to flip the coin. Let's say 50 times. Step 2, you identify your two outcomes, heads or tails. Easy. Step 3, you figure out the probability of success for just one flip. For heads, that's the 50% chance. And with just those three ingredients, you can calculate the exact odds of getting a specific result, like, say, getting heads 35 times out of those 50 flips. All right, so you get the idea. Coin flips are fun, but let's put this tool to a real test. It is time for a rapid-fire challenge I like to call the real-world gauntlet. First up, the situation that started this whole thing. You're staring down a 10-question true-false quiz, and you have absolutely no idea what the answers are. So let's be true to the math and not make a false start. What are the odds you can just guess your way to an A, getting 9 or 10 questions right? The probability is this tiny little number right here. That's just over a 1% chance. So yeah, while it's not technically impossible, you probably shouldn't bank on guessing your way onto the honor roll. The math says so. Next challenge, we're heading into the world of business. Imagine a telemarketer who knows that on average, only 1 out of every 100 calls actually ends in a sale. This is where the numbers get really dialed in. What's the probability they make exactly 5 sales in their next 100 calls? And the number is, wow, even smaller. That's less than 1/3 of 1%. See, this kind of math is super useful for businesses to understand performance and set goals for their teams that are actually realistic. Gauntlet round 3. Let's talk manufacturing. A company making bicycle parts knows that about 0.62% of their parts come off the line with a defect. You could say they're playing the long odds to make sure everything is top quality. So what's the probability that in a big batch of 124 parts, they find exactly 10 defective ones? Whoa, look at that number. The probability is incredibly, incredibly low. And this is a perfect example of how companies use this math. If a manager actually found 10 defects, they would know immediately that something was seriously wrong with the machines that day, because the odds of that happening just by random chance are almost zero. Okay, now let's shift gears and see how this very same math applies to something much more serious. This isn't just for tests or factories. It's an absolutely vital tool in health and medicine. For instance, in Great Britain, the 5-year survival rate for lung cancer is 8.8%. So if we look at a group of 10 people who are diagnosed today, what's the probability that exactly one of them will survive for 5 years? Using the exact same math, we find it's 0.384, or a 38.4% chance. This is how researchers and doctors can track how well treatments are working and understand major public health trends. It's powerful stuff. So from guessing on a pop quiz all the way to understanding global health statistics, this one idea, binomial probability, is so much more than just some formula you have to memorize for a test. It's a tool, a lens for seeing the world around you with a lot more clarity. So what's the big takeaway here? It's that you now have this awesome tool to see the hidden math that's literally everywhere. You can understand risk better, you can make smarter guesses, and you can decode all those stats you see thrown around every day in business, science, and health. So I'll leave you with this one final thought. Now that you know how to calculate the odds of anything with two outcomes, what everyday gamble, big or small, are you going to look at differently now? Thanks for watching.